Hello and welcome guys to my late night stream. Uh, it is 1 a.m. in here in Kuala Lumpur, so it's really a late night stream for me. By the way, please write in the comments where are you from, where you watch me from. So, what time zone are you at in? So, is that time is okay for you or not? So maybe I should schedule my future streams earlier or later, so please let me know. Is it comfortable for you to watch me in that time? So I don't think we will like spend much time working today because once again it's really late for me. Hopefully it will be maybe 1.5 hour or maybe 2 hours. But first let's quickly recap what have we done in the previous stream. So we've created a basic structure of our future application, of our backend part of our application. For those of you who are watching me the first time, we are building the personal finance management application. So, and in the last stream, we've made a basic structure. We've created some useful things such as we described our exceptions. We've created some interceptors for the HTTP requests, and yeah, we've just defined the basic structure. Basically, that's it. Today, it will be a really important stream because I'm gonna show you guys how we will describe our domain model of our application, because the domain model is really, really important thing. So yeah, for those of you who watch me the first time, I'm gonna build an application using the most modern, most like important techniques and using the modern tech stack. So the domain-driven design is kind of really popular, and it's really like modern technique of making the web applications. Let's quickly discuss what it is, and let's try to define the domain model for our application. So first, yeah, let me just start the timer. So as you know, every half an hour I will switch to the comment section and I will answer your questions. Okay, let's go. So what is a domain-driven design? Domain-driven design is a software development philosophy, and it's kind of emphasize the importance of like business model first. So we not just making like code, we are not just making in like some kind of logic, something like that, but we are aligning our software to business needs, and that's why it's much easier for us, for developers, to communicate with other business entities in our company. So yeah, the first thing is we are really focusing on business needs, business goals, and in business domain. Business domain is basically what our business is like operating in. For example, for our application, we are making the app for managing personal finances, right? So let's try to describe our business domain. Business domain. So first we will have some users, right? User should be able to log into our platform, and yeah, first is authentication and authorization domain. It's kind of a separate supporting domain in our application. Authentication and authorization. Next thing, after user logs in, user should be able to manage their accounts, right? An account is, it may be your bank accounts, it may be your like debit card, it may be your investment account, for example. It may be your some kind of an asset, for example, your car, your real estate, something that may generate your income, or maybe not only income but expenses. For example, you may have a credit account, and it means that you should give your money to a bank, right? So it's not only about the income but for expenses too. So users should be able to manage their accounts. Accounts management. Accounts management. So basically we need to create some kind of a CRUD operations for accounts. Create, read, update, and delete accounts. For each of these accounts, user should be able to create transactions. Transactions may be income or expense transactions. So either we add money to accounts or we remove money from the accounts and it's gone. So we should be able to create transactions. Create and manage transactions. What else? Yeah, and by the way, in order, so users should be able to create and manage transactions manually. It's kind of the most simple approach, but on this other hand, it's kind of the most annoying thing when you like put all your transactions manually in the application, and it's kind of like it sucks really. That's why we're gonna implement the second way of adding transactions is by using some kind of automation. For example, I'm thinking about using AI, OpenAI API, in order to, like, for example, how can I see it? I see that I can kind of upload a bank statement into our application. It will automatically parse it, extract all the data, all the transactions, and put it inside our application, and also categorize each expense and each kind of income into a separate category, and it will be super cool. Basically, I just upload my bank statement. That's it. I have all the transactions in my account. Sounds cool? Let's try to let's try to make it. So automation. Yeah, so there are like billions of banks, of different banks in different countries. So of course I'm not gonna support all their APIs, right? It will be like impossible for me. But using ChatGPT or any other LLM, it will be pretty easy just to extract all the necessary data from the document. Yeah, sounds cool. Okay, so accounts management, transactions management. What else? What else do we need? Let's think. Some kind of forecasting, and for example, what I mean by forecasting. For example, I have a goal of like having $1 million by the time when I will be 40 years old, and I need to calculate how much money should I put into my savings, how much money should I put into this account or that account, how much money should I invest in order to achieve my goal, right? So in order to do that, we need to make a forecast of my assets value in the future, right? So it is forecasting and backtesting, portfolio backtesting. Or for example, I don't know, I wanna know when the income from my investments, from my dividends will be enough for me to live a comfortable life without working, right? So just living on a passive income. So I just want to know when it will be possible for me. So it's also in the forecasting and portfolio backtesting category. So yeah, so let's start with these 4 tasks: authentication, authorization, accounts management, transactions management, and forecasting and portfolio backtesting subdomains in our application. Domain-driven design is kind of works really well with another approach that's called a clean architecture approach. So basically, in clean architecture approach, let me quickly Google it. Clean architecture. In the clean architecture approach, we have kind of a layered structure, as you can see here in this image. Let's try to open it. Yeah, something like that, like this. So we have several layers in our application, and it's kind of each layer is kind of independent of each other, right? So the most like basic level are entities. These are our domain entities. A little bit later I will explain you what it is. We have also basically, by the way, it's not really a good example. It's not really a good example. But anyway. Yeah, anyway. So we have like entities, which is the most like basic thing in our application. We also have such layers like application layer. In the application layer, we define all the logic of our application, all the logic of communicating between domains, between domain entities, value objects, and so on. And we also have the third layer is infrastructure layer, which kind of responsible for communicating with other systems, for example, with our database, with different like APIs, third-party APIs, and so on. And we also have the presentation layer. The presentation layer is responsible for for providing the information to a user or a client. In our case, it will be the front-end application or our mobile application. So the presentation layer is responsible for kind of transforming the entity to like, for example, JSON object that will be consumed by our front-end application. So yeah, as you can see, entities, use cases, which is an application layer that I described previously, and infrastructure. So it's kind of the most, it's like a different layer. And in clean architecture approach, I think this is the good example. Yes, this is the really cool image. Where is it? Yeah. So as you can see, it's kind of a flow from infrastructure to our entities. It means that our entities basically independent of our infrastructure. It means for entities points of view, it doesn't really matter what database we will use, how we will store our data, and so on. So basically, by implementing these 4 layers, we're making our application first secure. Second, it's really how do you say? It's really interchangeable. For example, we can in the future we may decide to replace one database with another, right? And it will be quite easy because we're just switching some entities, some like stuff in the infrastructure layer, and our entities may don't even know about it, right? So it's kind of I don't know, secure, stable, and interchangeable. It's kind of we are making an application by kind of like Lego bricks, right? So it's a modern approach, and let's use it. Let's use it. I hope that I tried to explain it, but believe me, it will be much easier to understand when I will start to code, and you will see how it looks like from this point of view. So in the previous video, if something is not clear for you, please put a comment and I will answer you in 10 minutes. But for now, let's start with making some abstract classes for our entities, for our domain entities. Not only entities, but all the stuff that we will use. It will maybe entities, value objects, some kind of events, messages, and so on. So the most basic thing is an entity. That's why let's create a new class, entity.base.ts, and let's put export class entity. Let's call it maybe base entity or entity base, or maybe just entity, it doesn't matter. And it should be abstract because we want our like actual entities to extend the base class, extend the abstract class. Export abstract class entity. So entities, and we will also have one more class which will be value object base.ts, and let's create value object, export abstract class value object. Okay, what is entity and what is value object? So basically the only difference is that entity is something that can have a unique ID, and value object doesn't have unique IDs. We can tell if one entity is equal to another by comparing their IDs. If one ID is equal to another ID, it means that these entities are equal. But we don't have IDs for value objects. It means that we should compare all the properties, all the fields of value objects in order to tell if it is equal to another value object or not. So let me give you some examples. For example, a user. A user is definitely an entity because each user has its own unique ID, right? An account. In our domain model, account is also an entity because each account has its own unique ID. Transaction, also entity because each transaction has its own unique ID. But for example, currency is a value object because currency doesn't have its ID. It might have some unique like characters. For example, USD for United States dollars, CAD for Canadian dollars, RUB for rubles, and so on. But in our case, it's not like we don't have to make these symbols as a unique identifier for currency. In our application, currency is really a value object because it doesn't really like mean something. Like it's not really important for our application. we don't have to like create new currencies in our application or like something like that. So it's a value object. What are another examples? It may be user address, right? Like city, street name, postal code. The combination of these fields is an address, and it each address doesn't have its unique ID, right? So in order to compare two addresses, we have to compare all the fields inside of this address. We have to compare city to city, country to country, street name to street name, and so on. So it means that address is a perfect example of a value object. Okay, so let's start implementing the base classes for these two things. Let's start with entity, and as I told you previously, each entity should have its unique ID. So that's why let's create protected abstract ID, which will be the type of aggregate. Not aggregate. Yeah, let's call it aggregate ID. And what is aggregate ID, and what is the what I'll explain you just in a moment. Aggregate ID, it is a type and it is a string. Something wrong? Yes, something is wrong. So why ID is abstract and what the fuck is aggregate ID? So in our application, each entity may have different types of IDs. For example, for user ID, it may be like UUID. It may be a string of UUID format, right? UUID. It is a string of, it looks like that. So there are a lot of symbols, a lot of groups of symbols, and so on. But we may also have some entities that use just a nano ID. Nano ID. It's a shorter implementation of like ID, but it's also possible to uniquely like distinguish each user by using a nano ID. But it just takes less space, less memory, less characters. So it may an ID may be nano ID, UID, UUID. It may be like something else, right? Because we don't know beforehand which format we will use for concrete implementation of the entity. So that's why we assume that each ID will be a string, but by making it abstract, we can replace it. For example, when we will be making a user entity, we may define that user ID is UUID. When we will implement something else, we may define that ID for that entity is nano ID or something like that. So we really making it abstract in order to redefine it in the future for concrete implementation. And what else? Each entity may have created add field. It also may have updated add field. So we will store the date of creation and the date of updates of each entity. But update add is not read only, because we will we will update it. So let's also define some getters and setters. Get ID will return the ID of the entity. Set ID will write the ID, but let's make these setter private, because we don't want to redefine IDs. ID is something like unique and we create it just once, and this ID will be assigned for an entity forever, right? So that's why we don't want like a random user to rewrite this ID. So let's make it private. So we will be able to set IDs only in this abstract class. Set ID. So far so good. It will return a void. What else? Let's also define getters and setters for created add and updated add like this. What else do we need? Yeah, let's make a constructor. No. Let's start with entity props. So each entity will definitely have its own ID, but it also will have some kind of a props. Props will vary from entity to entity. For example, user will have something like username, email, address, or any other user props. An account will have the props like I don't know, the name of the account, the type of the account, if it is an investment account or a bank account or some kind of an asset, and so on. So the props object will be different for each entity, right? Let's create protected read-only props of type entity props. And let's quickly define what is an entity props. Entity props should be a generic type. It means that we will define this type when we will create an entity, right? So let's put it here. So when we will create an entity, for example, by calling const, I don't know, user equals new user, right? We will put a type of entity props here, user props, something like that. So yeah, timer sounded, so let's switch to chat for 5 minutes. There are no messages in chat, and that's not good. Either you're not watching me or you're not interested in what I'm talking about, but come on guys, let's just quickly like chat with each other. Tell me where are you from, tell me what you want me to tell you, what should I put more attention to, something like that. Okay, so if there are no questions for now, I just switch to, I will like go for 5 minutes. So see you a bit later. Okay guys, let's get back to our application. Let's get back to coding, and I'll start one more timer, and yeah, let's continue. So we are defining our entity, right? So what do we need to do? Let me quickly, yeah, let's define a constructor for our entity. Constructor, about the constructor. So basically the good way to instantiate a new entity is by calling a create methods, by calling a factory method to create a new entity, right? So we are not like calling something like const user equals new user. It's not the best way. Basically we need to define some kind of factory. For example, it will be user.create, user.create. What the fuck? It doesn't let me write user create. Fucking cursor. Yeah, we are calling user create, and we provide all the data that is necessary to create a user inside the factory methods. That is really useful because we can put validation rules into that factory, and it will be easier for us to verify the values that user provides to this method, right? For now let's start with just basic constructor, I think. Or maybe, I don't know. Yeah, let's just define a constructor, and we'll see in the future what we'll have. Constructor. So for constructor we need to define the creation props, right? Create entity props. It will be a type create entity props, and let's define this interface. So we will have expert interface create entity props. We will have an ID, which is an aggregate ID. We'll have a creation date and update date, right? These are basically not create entity props, so these are like base entity props. Each entity will have this set of fields, definitely, right? But for creation, expert interface create entity props, we will need to define ID, which is an aggregate ID. We will need to define props of some type T, and we need to provide this type as a generic type, right? And we also may define created add and updated add fields, but if we will not provide these fields, it doesn't really matter because we can define it like on the fly, on the go. So for our constructor, these props will be of type create entity props, and we will extend it from entity props that comes to our entity class, right? Okay, so what is here? ID props create add and update add. Let's just structure it, and the first step, yeah, let's make it like that. So the first step, we set an ID that comes to our constructor. We set it to our internal field for ID. The second step is we put the props and we put the created add value if it is defined. If it is undefined, we just create a new date, which basically it is like the timestamp of the current date and time. Okay, so what else do we need? Before assigning props to our internal props field, first we need to validate these props, right? That's why let's call this validate props methods first, and only after that we will assign validated props to our internal field, right? And we also, yeah, so we have these props which are entity props, and we need to create a new private function, private methods, private validate props, like this. And yeah, we need to implement validation logic here. We need to implement validation logic here, but for that, let's create a new guard. Inside our libs folder, let's create a new file, guard.ts, and let's quickly define some like the most common validation rules that we'll have in our application. Okay, let me quickly rename it, make it lowercase. So export class guard, export class guard, and we will have some set of static methods. First of all, we need to check if the object is empty, right? If it is empty or not. But the value, it may not be not just string, it may be anything. So it is unknown. And if first we need to check if type of value is number, or if it is a boolean, we need to return false. If we have a number, or if we have like boolean value, it's definitely not empty, right? Always. If the value of a type undefined or null, it's definitely empty. All null values or all and undefined values are empty by default. What's next? What's next? If value is a date, if value is a date and we cannot get its time, it means it is empty. It is true. The next thing is if the value is a string but it is an empty string, we also return true, right? And yeah, by default we return false. By default we return false. So what else? We need to check if it is an object and if it is an array. If type of value equals object and object keys, if it is an object and it doesn't have any keys in it, it is empty. Yeah. So, and the next step is to check if it is an array. If array and it doesn't have any values inside an array, it is also empty. Yeah, I think that's it. We are done with this validator, and let's create one more validation here. Static method length is between. So we also need to check if the length of the property lays between some kind of min value and max value, right? So for that, but it's not only about strings. It may be unknown too, right? No, it may be a number, string, or an array of something. Like that. Yeah. So we'll have a value, some kind of value, minimal length and maximal length. And first let's check if it is empty or not. So we are calling if guard dot is empty. It means that it's definitely not between these min and max values, right? We just return false. No, we can't just return false. Let's throw an error. Throw new error, value must be defined. Value must be defined. Cannot check the length of a value. Value must be defined. Okay, and we need to check the length of the value. Basically, if const value length equals, if this type of value equals number, we just return, we need to convert value to string, and to check its length, like that. In other cases, we just take value.length, both for strings and for arrays. Value.length will return the length of the value. It sounds really stupid, but it is that it is, right? And basically, if value length less than minimal value or value length more than maximum value, we just need to return false. And in our cases, we just return true. Return true. Yeah, that's it. Okay, so let's go back to our entity, and for validation methods, let's quickly implement the logic. So validate props. We need to check if it is empty or not. So if guard dot is empty, props, let's throw new error, entity properties must be defined. Entity's properties should not be empty, right? The next thing, we need to check if the props are an object, and if the props are not an object, we need to throw an exception. So if type of props doesn't equal to object, we need to throw new error, entity properties must be an object. And by the way, we in the previous stream we created some basic exceptions for our application, and we have argument invalid exception. Let's throw it. So instead of throwing new error, we will throw argument invalid exception, like that. Entity properties must be an object. Yeah, cool. In that case, let's also throw argument invalid exception. Throw new argument invalid exception. Entity properties must be defined. Yeah, that's cool. Next thing is let's check if the entity has a required number of properties. For that case, let's define that any entity may have only maximum of 50 properties. Not too big, not too much, not too less. So let's define const max properties equals 50. Maybe we should make it even less. And let's check if object keys object keys properties dot lengths more than max properties, we'll throw new argument invalid exception. Entity properties must have less than max properties. Yeah, let's throw argument out of range exception. It will be better in that case. Argument out of range exception. Cool. Okay, so we have ID, we have properties, we have created add and updated add fields. What else do we need to do? Each entity may have its own validator. For example, for users, we need to validate that it has like the username has no. For example, user password should contain special characters, right? It is a custom validation rule for our user entity. Or, for example, user name must not be less than 2 characters, for example. So these are custom validations rules only for user entity. So that's why we need to create one more method, and we should make it abstract in order to define it in the concrete implementation of the entity class. So let's create abstract validate method. It should return void, and we will use this method to make custom validations in the future. And we also want to call these methods when we create a new entity in the entity constructor. This dot validate. If something goes wrong on this step, we just throw an exception. Okay, so what else do we need to do for an entity? Yeah, let's define checker static is entity. So this method we will use it in order to define if it is an entity or not. So if some kind of an object is entity, or maybe it is a value object. So for that we will create static method is entity. Entity is unknown in that case, but if it is an entity, we will return that entity. So yeah, so basically we check if entity is instance of entity, and we just return true in that case. Yeah, so it's kind of custom, not a validator, but type checker Yeah, type checker, I believe. What else do we need to do? Let's think. Validations are done. Static checker is done. We need to, yeah, we need to create a couple more methods. First method, it is equals method. We will use this method in order to define if one entity is equal to another entity, right? So we will use object, which of type entity, and we will return true or false. If object is null or object is undefined, we will return false. But in that case, we may just check with our guard. We may check with our guard. So yeah, first we check if the object is null or undefined. It means that definitely one entity cannot be equal to null or undefined value, right? We return false. If the object is equal to this instance of entity, it means that they are equal. We return true in that case. If the object is not instance of entity at all, right? But in that case, we may use our newly created function isEntity, right? So we just need to replace that stuff here. If not entity dot isEntity for object, we return false. And yeah, so if this dot id equals object dot id, so if IDs are equal, we return true. We return true. Yeah. So our comparing function is ready. Next thing, we need to define a getter for our properties. We have getters for created add and getter for updated add, and let's quickly define a getter for properties. Getter for properties. Let's make it a public function. Public get props. We want to return entity props, and base entity props, but maybe it is redundant because entity props will definitely has base entity props, right? Yeah, it should have. It should hasn't like all these standard fields. Okay, anyway, public get props, we will just decompose properties, and we will put id, create add, and updated add. That's it. Like that. No, let's create that way const props copy. So that basically we're creating the copy of the object with all the properties, IDs, created and updated add fields, and we will return object.freeze. Object.freeze prevents any client of modifying fields of this entity, right? So we just return like a static copy of all the props of our entity. What else do we need to do? And let's create a we also need one more function, and we need to create a function to object. public to object. In that case, we need to convert all the properties, all the value objects that may be inside of this entity to like a basic JavaScript object representation. For example, in order to pass it through like as a JSON representation, right? So yeah, let's create these methods quickly, and I'll switch to chat. To object will return unknown, because we don't really know beforehand what the shape of the object will be, right? Unknown. And we have like plain props. For a plain props, we need to convert properties to an object. So let's create convert props to object function, and we will implement it in the future. But for result const result, so we have an ID, we have created add, updated add, and all the props, and as in the previous example, we will return object.freeze result. Let's run. What's wrong? Ah, sorry, just a typo. Yeah, I think that's it. Let's switch to our chat. What do we have here? The chat is still empty. It means that I'm taking a small pause, and I'll get back to you in 5 minutes. See ya. Okay, guys, let's quickly continue. To be honest, I feel a bit sleepy right now because it's already 2 a.m. in the night for me. So let's continue working on and let's finish our day. We need to implement convert props to object function. For that, we need to create a new utils.ts file, and we need to define this function export convert. What's the name? Convert props to object. Let's copy that and paste it here. Convert props to object. Like this, and props are unknown. Convert props to object, like that. So let me quickly copy the function definition from my template, and it will be just quicker, and I'll explain you guys what I've done here. So first we creating props are unknown. Yeah, so first we're creating a structured clone of our properties. So basically we just copy one object to another object as it is, and for each property in that object we are checking if it is array or not, and if it is an array we just like making we just calling the function by itself, right? So we check it once again if it is we're trying to convert the child elements of an array to an object. So and in the end we just return the props copy. So basically we just calling the structured clone function for each element of the original props. But I don't like the thing that my linter is kind of like complaining. Let's quickly fix our linter rules. Where is it? Yes, lint config mgs. Yeah, let's quickly fix it. I think we need to replace this one, not type checked, but just recommended, and it should be okay now. Let me quickly restart ESLint server. And yeah, we don't have convert to plain object function. Let's quickly copy it from my template. Like that. So what the fuck? So yeah, we don't have a value object still, but we will have it in the future. I just copied it from my template, so but don't like we don't give a fuck about that right now. We just want to check if it is we want to convert entity to an object right now, and after that we just call in the structured clone function for each element, for each key of the entity, for each property of the entity. What's wrong here? What's wrong here? Yeah, now it's better. Now it's better. We'll have value object in the future, but basically we just, like as I told you previously, we're just converting each key value pair of an entity to a plain object in JavaScript. For now, yeah, let's import this function here, like that. What do we need to do? Yeah, I think that's it. We are done with our entities. So let's make a quick recap. By the way, let's make it protected in order to create entities using a factory function. And I'll show you guys in the future how we will implement it. So, for example, in the future, we'll have a class user that will extend our base entity class, right? And we'll have like custom validator for that entity. We will check if, for example, if the name of the user is defined or not. And for creating an instance of that user entity, we'll need to define a function, static function create. Static function create will have some props, and this function will return a user. It is just a basic factory method. Yeah, so that's why when, for example, if I'll try to create a new user by calling new user, it will not be possible because we have a protected constructor, right? As you can see, constructor of base class entity is protected and only accessible within the class declaration. So it means in order to create a new user, I'll have to call a create factory methods like that. And as you can see, there are no errors now. And in that create method, we can define more validation rules. But on the other hand, it makes no sense because we already have our validator, right? And we call in validation in the constructor. Let's not complicate things. And let's not make it protected for now. Maybe in the future I will change my mind and we'll make it protected, and we'll have to define a factory methods in order to create a like a child instance, like in order to create instances of this entity. But for now, I think it's okay just to have a constructor. Let's quickly switch to our value object, and I want to finish with value objects today. And oh, I forgot to start a stream. I forgot to start a timer. Let's quickly create a value object. Because it's too late for me right now, and I just want to go to sleep. So yeah, we'll have an abstract class value object. This value object will be extended from some type T, which we don't know beforehand what this type will be, right? And it will have protected read-only props of that type. So but I think we should make a couple of adjustments. First, we need to our value object may not be an object by itself, right? It can be a string or a number or date. So it may be a primitive value. It may have a primitive value, or it may be an object, right? We don't know beforehand what it will be. So that's why let's define a custom type primitive, which may be string, number, boolean, null, or undefined. It might not be null or undefined, to be honest. Just string, number, or boolean, right? And let's also define interface domain primitive. We'll have some kind of type T, which will extend primitive value, and it may be primitives or date, and in case if it is an object, it will have just in case if the value object is just a primitive, is just a string, number, or boolean, or date, right? We will keep its value inside a value property. In all other cases, if value object is just a plain JavaScript object, we will not keep that structure. So we'll have only value equals something only for primitive values. Okay, so yeah, and that's why we need one more type, export type value object props of t equals t extends. If this t extends primitives or date, it will be a domain primitive, or it will be just a t, as I told you right now. So our properties will be a value object props of type t, like this. We'll need to define a constructor. And we need to perform a couple of checks. First, we need to check if it is empty or not. We need to call a validation function, and only after that we will write these props that comes to our constructor to the internal props of our value object. But first we'll check if it is empty or not. Check if empty. Then we call a validator, this dot validator. Yeah, and only after that we write the properties to our value object. So the validator as for entities and for value objects too, it will be an abstract function which we will define in the actual implementation of that value object. So protected abstract function validate. Yeah, that's it. We also need to create a static checker if it is a value object or not, and we will return true if the value is instance of value object, which makes sense. Value is a type of unknown, and we will return a boolean value. Value is value object of type unknown. Yeah, it makes sense. Then we need to check if one value object is equal to another value object. So for that we will implement a new method, public equals. So we will have some kind of value object of type t, and we need to check if it is empty or not. So if it is null or undefined, we will return false. Just the same stuff as we done for entities. If it is null or undefined, it cannot be equal to another value object, so we return false. In other case, if it is not null or undefined, we just compare stringified values of these objects. We call in JSON stringify for the original value object, we're calling JSON stringify for the second value object, and we just compare it with each other. Okay, so the next step, we need to create a method to convert value objects to a plain JavaScript object. Let's call it unpack, public unpack. We will just return a type t, like original type t. And first we need to check if it is a primitive or not. If this dot is primitive or not, we will return the value key. Or we will return a copy of that object, by calling convert props to object and returning object.freeze. So it's the same stuff as we done for entities. We just need to add one more validation. We need to check if the value object is a primitive or not. If it is a primitive, we just return the primitive value that we keep here. On the other hand, another like scenario, if it is an object, we convert each key of that object to like a plain JavaScript object, and we call it object.freeze in order to make it read-only. So nobody will not be able to modify the state of that object, right? So we've done the same thing for our entities. So let's create a method private is primitive if and the value is primitive if the value is string, number, or boolean, right? No. Because we need to check if our object has a value key. If it has a value key, it means that it is a primitive. So no. What's wrong? What's wrong, guys? Yeah. So if object dot has object prototype has own property, and we need to check if it has a value or not. If it has a value or not, we return true. If it has value, we return false if it doesn't have a value key inside. That's it. And we also need to implement this method. Check if empty. So it will be private check if empty. If props is null or props is undefined, but by the way, we can call our guard that we created previously. If guard dot is empty, or this dot is primitive and guard is empty for primitive, we throw an error. We throw new argument not provided exception. Property must be provided. So what's wrong here? Why is it complaining? Property value doesn't exist in type value object props t. Makes sense. Makes sense. But on the other hand, we just return in. Let's ask AI what's wrong here. I think I missed something. But I'm not quite kind of understand what's wrong. Fix in chat. Okay. Ask, send. Let's see what we'll have from AI. Try asserting these props to the main primitive before accessing the value property. It makes sense. It definitely makes sense. But yeah, I made an error here. And this, if it is a primitive, yeah, so yeah, sorry if that was my mistake. So yeah, I think we are done with value objects. So basically, as I told you previously, entity will have an ID, value objects will not have any ID at all, and value objects may be a primitive value. In that case, we will keep that primitive value inside. It will also have an object like kind of structure, but we will keep that primitive value inside this object under value key, right? And we may compare two value objects by comparing each key. So if both value objects has the same set of keys and each key value has equals to the key value of the other value object, it means that these value objects are equal, and only in that case. But for entities, it's much easier. We can just compare entities IDs. If one ID is equal to another ID, we are done. Entities are equal. But for value objects, we need to compare all the keys, all the values of all the keys, and only if everything is equal, it means that two value objects are equal to. Okay, we're done with value objects. We're done with entities. We created two base classes, right? And let's just import value object here too, to make our utils work as it should be. What else do we need to do, guys? What else do we need to do? One more important step. The next thing we need to implement is an aggregate root. Aggregate dot entity, nope, aggregate dot base dot ts. What is an aggregate? Aggregates, it's kind of like a super entity. It is an entity that may contain another entities as childs or another value objects as childs, and it may also has some kind of domain events and how to explain you, it's kind of a container, immutable container. For example, let me quickly show you like basic example. We may have a user aggregate which can contain address value object. It may have for example some fields like name, surname, username, which are just like primitive values. But user aggregate may have child entities too. For example, it may have sessions entity. It may have an array of sessions of a user. A session by itself is another entity, and user entity, user aggregate, may contain this session. But what's the point of aggregates For example, if we want to update user entity, or if we want to create a new session for user, we are not calling session.create. We are not referring to a session entity by its by so we are not calling session class at all, right? We are referring to session entity by calling methods from aggregate entity. So all the communication goes through the aggregate to the child entities. I hope it makes sense. And for example, each user may have I don't know, each user may have a subscription. So if we are making a paid application, in order to use our application, user should subscribe and pay us some money, right? And each user may have some kind of like a assigned subscription, what type of subscription user purchased previously. And that subscription type is also an entity. But to create, no, that's a bad example, I think. That's a bad example. But just think about it. User will have a subscription type, which is another entity, but user aggregate will contain this entity inside. So that's the point of aggregates. It's kind of a super entity that can hold another entities and another value objects, and also it can hold a domain and raise domain events. I'll tell you about domain events a little bit later, but just for now, let's just quickly start implementing this base class. Export abstract class aggregate root. And as I told you previously, it is an entity, so it should extend the basic entity class, right? So for that, so let's extend entity. Okay. Aggregate root will also have entity props, and these entity props will be the same here and there, right? So as soon as we are extending the basic entity class, it means that all the properties that are required that already defined, like ID, props, created, updated, and like all the getters, all the setters, and so on. We just need to make like unique features of aggregate root that I told you previously, and we need to define them. First unique feature of aggregates are domain events. So let's create domain events array here, and domain events will be of type domain event, which we will implement in the future. For now, let's just leave it as it is, and we need also to define a getter for that domain events property, and let's also define a protected method to add event to that array, right? So we just calling the push method. It's just a basic array. We are calling push, and our domain event goes to internal domain events array of that aggregate root. We need also to implement a method to clear domain events like that, and we also need to publish these domain events. So imagine that we may have like several aggregates in our system. We may have for example, user aggregate. We may have an account aggregate, which can contain, for example, transactions, so it is an aggregate. And in order to communicate between different aggregates, we need to raise domain events. So for example, when user creates a new account, or user puts a new transaction into an existing account, we are communicating between two aggregates. And basically, user aggregate will send an event to a different aggregate, to an account aggregate, and account aggregate will subscribe to that event and make some like internal logic based on the event that it consumes, right? So just remember that two different aggregates communicate with each other by domain events, but like child entities, child value objects, we can communicate with these child entities by calling the aggregate root methods, built-in methods. Yeah, you'll see how it will be implemented in the future, but for now let's just finish our base class. So we need to publish our events. Publish our events to a different entity. Public async dispatch events. And we will need to call event emitter for that. We have already installed this event emitter from Nest.js in our application, so we can just like inject it. Event emitter 2 like that, and we also need, I believe, a logger. So logger, it is a logger port. We will define logger port a little bit later. Yeah, we didn't define it in the previous video. Okay, we have logger, we have event emitter. So what should we do? We need to await for all promises. Await promise.all. These domain events, we are just calling each domain event from that array. Oh, my timer just finished, so let's finish this task and let's go to the break. So we are calling for each event, we are calling logger, right? Logger dot, for example, not info but debug. Logger dot debug dispatching event with the event name, right? But let's enhance that message. Let's enhance that message. Let's enhance this message later, but for now let's just quickly, we need to return event emitter.emit async function, which we will call for each constructor dot name. So we want to call this emit async function for each of the events. And what's wrong? Let's fix it later. And after calling this function, we need to clear the list of the events. So we call this dot clear events. Okay, so we need to fix a couple of things. First, we need to create this logger port. It will be quite easy. And then we need to fix, I think, our ESLint rules, because we still get some like complaints, but I don't quite understand why we have these complaints. Yes, I think it's pretty safe here. And let's switch to domain event base class. Okay, so I'm starting a pause. I'm switching to the chat. Let's see what we have here. The chat is empty. It means that I'll get back to you in 5 minutes. See ya. Okay guys, the last step of our today's stream. Let's start the timer and let's finish it. So it is complaining about unsafe augment of type error. Let's just make it as string for now, but I think we will need to fix our ESLint rules in the future. And let's enhance our logger message. Let me quickly check. Yeah, I think we need to dispatch events. Dispatch events, we have a logger, right? Let's I'm thinking how to make it better. I'm thinking, but okay, for now let's just do the following. We will just get our CLS from CLS manager dot get CLS service, right? CLS is the thing that we implemented in the previous stream. It basically can kind of retrieve all the context from the request and put it inside the context of our application. So for example, we are catching all the request IDs, we're catching all the user IPs, and for now let's just put this request ID. So CLS dot get ID. So we put this request ID inside our logging message, and we need to get the event name, right? We need to get an event name. So event dot constructor dot name event dispatched for aggregate this constructor name. Yeah, and let's also lock the ID of an aggregate. That's we need to create a new folder in our libs folder. Oops, sorry. Libs, new folder, ports. Let's define a logger interface. Logger.port.ts, and let's quickly define an interface for our logger. For that, I'll just copy the value from my template and paste it here. So we just have a basic interface logger port. So it means that each our logger instance will have these methods: log, error, warn, and debug, right? And in our aggregate base, we just inject this port here. It will be, all the ports are useful for dependency injection. So it means we do not inject the concrete implementation of the class. We inject just an interface, and our dependency injection mechanism will inject the concrete implementation based on the rules that we define in our application. For example, it means that we have just one logger port interface, right, which has these methods. Maybe maybe now we just want to log our messages to a console. It will be just one concrete implementation of our logger port. In the future, we may want to replace this logger, our console logger, with, for example, cloud logging. We will want to log our messages to AWS or Google Cloud or something like that, or CloudWatch. It is another concrete implementation of our logger port. It will have all the same methods, but each of these methods will have a different implementation. Yes? So in order not to work with a concrete implementation, we just work with an abstract interface. It's just easier, and our dependency injection mechanism will decide which concrete implementation, either it will be a console logger or it will be a cloud logger, which of these will be injected to our application based on different rules that we define later. But we operate with just a port interface. Okay, so, and I think we're done with aggregate root, and we need to switch to the main event. For that, let's create a new file, the main event.base.ts. The main event base.ts. And let's define a base class for our domain events. We need to create an abstract class, export abstract class domain event, like this. Each domain event will have its own ID, public read-only ID of string. Each domain event will also contain the information about the aggregate ID that's called that domain event, public read-only aggregate ID, like this. And each domain event will also have some metadata, so it will be public read-only metadata of type, oh, what the fuck, domain event metadata, like this. So let's define this class, or sorry, this type domain event metadata. So what it will contain? It will contain the following information. First, it will have a timestamp of when this event occurred, right? It will be just a number. Second, we need a correlation ID. Correlation ID is kind of like unique ID. In our case, it will be a request ID that we keep in our application context, right? So read-only correlation ID, which is a string. We also need a causation ID. Causation ID, for example, we may chain domain events. One domain event can cause another domain event, and another domain event can run another domain event, and so on. So we can kind of have a chain of these domain events. And in order to debug it properly, we need to understand what happened before the domain event. So what event caused these domain events? So that's why we need a causation ID, and it is definitely an optional property. So maybe there is no previous domain event at all, right? And also we need to keep user ID. So which user is associated with that domain event, which is also optional, because we may have some system events that is not related to any user, right? So, and so we have metadata for each of the events, and let's define a constructor. So in constructor we will have some props, which are domain event props of type unknown. We will define this type in a moment, but first we need to check if it is empty or not. If guard dot is empty props, it means that we should raise an error. In that case, the main event props cannot be empty. So throw new argument not provided exception, props must be provided. Okay. After that, when we verified that our props are not empty, we need to create a random ID for that event. So this dot ID equals crypto dot random UUID. So we're just creating a random unique ID for that event, and we need to assign the properties. So this dot aggregate ID equals props dot aggregate ID. This dot metadata equals to so let's first define domain event props. So we will have aggregate ID of string and payload of type T, but it's not a payload, it is a metadata, but not of type T, but of type domain event metadata. And we need to omit from T types of ID and metadata, just in order to make it type safe, right? So let me explain. We are passing here like some kind of a type. We don't know yet what is the type, but we remove from this type ID and metadata fields, if any, and enhance it with aggregate ID, which is string, and metadata, which is our domain event metadata, right? Yeah, I think that's it. So this dot metadata equals, and we just need to fill these fields: correlation ID, props metadata dot correlation ID, or we need to get this ID from our context. That's why we need to call for CLS const CLS equal CLS service manager get CLS service, like this. And as we done previously, we just call CLS dot get ID. So we retrieving correlation ID either from metadata if it is defined, or we just creating a new, not creating, we just retrieving the correlation ID from our global application context by calling cls.getID. Also, we need to define causation ID if it is defined from in metadata, and we also need to define timestamp, which will be props metadata dot timestamp or the current timestamp, right? And we also need to define user ID from props metadata user ID. And that's it. That is a base class for our domain event. We need to go back to an aggregate, and in aggregate we need to import this domain event here. What's wrong in our entity. Something's wrong with guard. I think it is because we... What's wrong? Yeah, now it is okay. Now it is okay. Yeah, it's okay. So we finished our domain events base class. What else do we need to do? Let's think. Yeah, as I told you previously, another really important like concept in domain-driven design is a concept of repositories. Repositories are responsible for communicating with third-party systems such as databases, third-party APIs, some kind of like event managers, or like anything like that. So anything that is not related to our application, some third-party systems, it is the responsibility of a repository to communicate with that stuff. So it's kind of an abstraction on top of that systems. So for that, let's define a base repository port, I believe. So in that case, we will define a port for database repository, right? So the basic like structure, the basic methods that will have all the logic for communicating with our database. Just the basic operations. So let's create new file, repository.port.ts, and let's define here export interface repository port. Repository port should depend on aggregate like this. Why cannot I import it? What's wrong? Export class aggregate root. Let's call it just aggregate. Okay, so aggregate. What's wrong? Import aggregate from aggregate base. Okay. And what are the basic operations? So we need to insert something to our database. Insert something. So it should be either one aggregate or an array of aggregates. What's wrong? Why it's not... What's wrong? Because we cannot extend. Okay. So let's just, let's keep it like that. So we need to insert something. We also need to find something by its ID. Find one by ID, and ID should be a string. And in that case, we need to return the aggregate, or will not return anything at all. For example, if we wasn't able to find an aggregate by its ID. Let's quickly install a really useful library that I use all the time. It is called Accid, which contain the base like interfaces and methods for the case. So npm add accid.ts. accede.ts. Okay, accede is installed. So when we call find one by ID, we will return a promise, and this promise will contain a result which will we import from accede. Result, so it will be either aggregate or it will be an error. Aggregate or error, like that. So result accede, result from accede, it is really useful because we will have either OK type or error type, right? And we can adjust our logic based on the result that we get from the operation, right? I'll show you how it looks like in the future, but trust me, it is a really cool pattern. I think it's just called result pattern. Maybe it comes from, like, I know that's it's very popular pattern in Rust programming language, so it's kind of mocks this Rust package, but in TypeScript. What else do we need to do? Find all. Find all. We will get just the promise, and we'll get a result of an array of aggregates or an error, right? What else? Find all paginated. It means that we will call this method if we want to get the paginated response, right? First, we need to define a paginated params, and we will get promise of result of a paginated aggregate or error, like this. We also may want to delete something. Delete something by its ID. Like this. And we also need to define a transaction. So for example, if we want to make make some changes in our database in batch, so we need to define a transaction for that. In that case, transaction T, it will have some kind of a handler, which will be a function that returns a promise of type T, and after that it will return a promise of type T. Something like that. Okay, so let's define paginated params type. But let's call it paginated query params. So paginated query params export type paginated query params equals, we need to define a limit, the current page, not the current but the requested page for pagination, offset, but offset is you can calculate it, right, based on the limit and page by itself. So we don't need offset, I believe. We don't need offset. What else? We need to define order by something. And order by, let's define it as a separate type, export type order by equals field, which will be string, or and like direction. It should be either ascending or descending, like that. So my timer is finished. So let's finish this repository port and we can call it a day. I think we will see each other on the next week, but I'm not sure about the date when I'll be ready to stream. Let's just finish it and let's discuss it later. So paginate query params are ready, right? And we also need a paginated class. So let's create a new class, export class paginated for paginated results, paginated of type T, which we don't know beforehand. So it will have a count. How many items do we have? We will have a limit. We have a page, and we have some kind of a data of type T. And in the constructor, we just need to write these properties. Okay, that's good. That's good. So I think we're done. We just create our repository port, which will have some like most basic and common operations for our database repositories, which are insert something to our database, find something by ID, find everything but return paginated type, and we can also delete something, and we may launch a transaction for like batch modifications in our database. All these methods return a promise of a result type. Result type is imported from Axid.ts, and it helps us to easily understand what kind of return type we got. It can be either OK type or error type. So it's kind of like type safe methods for retrieving data. Okay, so I think that's it. Let's make a quick recap and let's kind of schedule next stream. Today we implemented the base classes for our domain-driven design model. The base classes are entities, value objects. As I told you previously, the difference between entity and value objects is that entity has its own ID, but value object has not its own ID. So to compare one entity with another entity, we can just compare its IDs. For comparing value objects, one value object with another value object, we need to compare all the properties of these value objects and all the values of these properties. We also created an aggregate class, which extends the basic base entity class. Aggregate is some kind of a super entity that may contain other entities as childs, and aggregate also may contain some domain events and dispatch these domain events. Domain events are required in order to different aggregates to communicate with each other. So we can call some kind of methods from different aggregate by raising a domain event and by subscribing another aggregate to this domain event. I'll show you how to implement it in the future. And we also create a basic repository port. In our case, it is just a basic set of operations to communicate with the database. These operations are insert, find, and delete. That's it. Thank you guys for watching my stream. I think that the next stream will be the next week. Sorry, I think it will be on that week, maybe on Saturday, maybe on Sunday. So yeah, either 15th of March or 16th of March. So once again, guys, thank you for watching my streams. Thank you for listening to me. Subscribe to my channel, hit like button, put some, please provide me your feedback. So tell me what was okay, what was wrong, in order to make my streams better for you in the future. So thank you guys, see you in the next stream. Bye.